cosmic recipe has all the ingredients for an awesome planet, and 4.5 billion years ago, it started mixing. First, you need lots of dust. Then add a massive space hunk of rock. Next, chuck in some volatile compounds and mix it all up with a few rogue comets. Now let gravity do its thing, and ta-da, you have planet Earth. Well, almost. That cosmic concoction didn't just magically whip up our home turf. There were a lot more steps involved in the process than that. Here are 6 ways that Earth was made. No. 1. Unearthing Earth's birth. To find out how we got our gorgeous globe. Scientists are literally digging deep into the stuff that makes it. Literally. In 2022, researchers analyzed samples from the deepest mine ever dug, more than 12 kilometers below the surface. Their goal was to learn about the composition of Earth's core, which is impossible to study directly since, well, it's in the center of the planet. Their findings provided new insights into how Earth formed. They found that the deeper they went, the higher the concentration of iron and magnesium became. This is important because it supports the idea that Earth was formed by a bunch of smaller bodies colliding and sticking together. Those smaller bodies were like building blocks, each one adding to the growing mass of our planet. As Earth grew larger, the gravitational pull at its center increased, causing elements like iron and magnesium to sink toward the core. So the deeper the researchers dug, the closer they got to finding the primordial building blocks of Earth. But there's still a lot we don't know about the planet's core. Scientists think it could be a liquid outer core surrounded by a solid inner core. But exactly what those cores are like is still a mystery. It's hard to study them directly, so we may never know everything about them. But thanks to this super deep mine, we learned a lot more about what's below our feet. Number 2. The incredible journey of Earth. From the tiniest atom to the largest star. Everything in the universe is made of a combination of 7 basic elements: hydrogen, helium, lithium, beryllium, boron, carbon, and nitrogen. These are known as the cosmic recipe. Before Earth existed, these elements floated around in a giant cloud. Maybe they were spewed out after a nearby star exploded, or they were just hanging out after forming from the Big Bang. Either way, they were in a big mess until gravity intervened. The story goes that gravity pulled the dust particles together, creating clumps that became the building blocks of rocks. Over time, those building blocks collided and stuck together, eventually forming planetesimals, the earliest version of planets. Eventually, one planetesimal got big enough that its gravity overpowered everything else, including the sun. That's when Earth became a planet. But it wasn't done gathering ingredients yet. Comets, asteroids, and meteoroids bombarded Earth, bringing more material to the growing planet. Some scientists think this is how Earth gained most of its mass. Others say Earth's building blocks were just really good at sticking together. Either way, the cosmic recipe was complete. Earth had all the ingredients it needed to become the home of life as we know it. No. 3. How planet Earth was forged in the cosmic crucible. For the first few billion years of Earth's existence, it was a wild ride. It wasn't just asteroids, comets, and meteoroids smashing into the young planet. Earth itself was in a constant state of flux. Molten magma flowed across the crust, reshaping continents and oceans. Volcanoes rumbled, spewing gases and dust into the sky. And the whole planet was hot. Earth was a true cosmic crucible where the ingredients of life were forged. This intense heat was partly due to the fact that Earth was still forming. All of that crashing and smashing generated a lot of energy. Plus, radioactive elements deep within the planet released heat as they decayed. But as Earth cooled, things changed. The gases that had once filled the atmosphere condensed and fell to the surface as rain. Over millions of years, they formed the first oceans. And as water flowed across the land, it carried away debris and sediment, carving out valleys and filling in low areas. Earth was finally taking shape. but there was still a lot of work to do before it could support life as we know it. Number 4. Beneath the surface. While the surface of Earth was cooling, strange things were happening beneath the crust. After all, we're talking about the period of time before Earth had a solid surface. As the planet began to form, a dense, hot ball of rock and metal gathered in the center. This core is still there, and it's responsible for Earth's magnetic field and its ability to support life. But it wasn't always smooth sailing. As Earth grew, pressure and temperature increased in the core, causing the elements inside to rearrange themselves. Heavier elements like iron and nickel sank to the center, while lighter elements like oxygen and silicon rose to the surface. This process, called differentiation, created Earth's core and mantle, but it also led to some serious volcanic action. As the core and mantle formed, molten rock erupted onto the surface, releasing gases and changing Earth's composition. Over millions of years, this volcanic activity created Earth's first solid crust. But the crust wasn't just rock. Thanks to the outgassing of volcanoes, Earth's early atmosphere was filled with gases like water vapor, carbon dioxide, and nitrogen. These gases formed clouds that eventually rained down, creating the first oceans. Meanwhile, Earth's surface was still pretty rough, but over time, wind and water eroded the rocks, smoothing out the landscape. Number 5. The birth of a planet. Scientists use a variety of tools to study how Earth formed. One of the most important is computer modeling. By simulating the conditions that existed when Earth was forming, scientists can get a better understanding of the processes that shaped our planet. For example, they can study how gravity pulled dust particles together to form planetesimals. They can also model how Earth's atmosphere evolved over time. Computer modeling has helped scientists make some incredible discoveries about Earth's formation. For example, one team used computer models to simulate the early stages of Earth's formation. They found that the planet's core could have formed in as little as 10 million years. Other scientists have used computer models to study how Earth's atmosphere evolved over time. They found that the early atmosphere was probably very different from the one we live under today. It was probably much thicker and had a lot more carbon dioxide in it. Thanks to computer modeling and other scientific tools, we're learning more about how Earth formed every day. We now know a lot about the ingredients that make up Earth. We know that it's mostly rock and metal, but we also know that it contains a lot of gases and liquids. We know that Earth is made of layers, each with its own unique composition and properties. And we know that the planet has changed a lot over time. But there's still a lot we don't know. We don't know exactly how Earth formed, why it has a magnetic field, or how its atmosphere evolved. But thanks to tools like computer modeling, we're getting closer to understanding the amazing planet we call home. If you want to know more about how Earth was made, then check out the links below. You can learn more about the cosmic recipe, the incredible journey of Earth, how planet Earth was forged in the cosmic crucible, beneath the surface, and the birth of a planet. Don't forget to subscribe for more amazing science videos. Thanks for watching.